Hi, so we're in section 1.3, multiplication of whole numbers, and this is part 2. So last video we went over multiplication facts of single-digit numbers, and today we're going to combine them to do multiplication problems like more with more digits. Okay. So the first problem I want to look at is 76 times 6. And notice how I wrote that problem with a dot, and that is the same, that is an alternative notation to the times symbol, okay? So it means exactly the same thing, all right? The dot is up higher, it's not a decimal point. Decimal points would be at the same level as the numbers, but this one is in the middle, vertically in the middle. Okay, so we're gonna look at this and we're gonna rewrite the problem vertically, lining up the ones digits as we did in arithmetic and in addition and subtraction. Okay, and then so we'll take 6 times 6 is 36. We put the 6 down here in the ones place and carry the 3. And 6 times 7 is 42 plus 3 is 45. And that's an example of multiplying a 2-digit number by a 1-digit number. So our next multiplication that we're going to do is going to be 400, which is a 3-digit number, times 60. Okay, we're going to write it vertically and line up the ones digits there so that place value continues to mean what we want it to mean. All right, and we're going to work. First, we're going to be multiplying by the digit in the ones place, and we're going to multiply, and because it's in this place, the first thing we write is going to be right underneath. So 0 times 0 is 0, 0 times 0 is 0, 0 times 4 is 0. Good? And now we're going to multiply everything by 6, well, the first number, 400, by 6. And because the 6 is in the tens place, we're going to put the answer to the first multiplication problem in the tens place. So we're shifting it over to the left. So 6 times 0 is 0, 6 times 0 is 0, and 6 times 4 is 24. And now we just add these up. Okay, and that's our answer. So we do have a little trick for multiplying when you're working with a lot of zeros. So another way to do this problem, if you multiply the non-zero pieces, so the 4 and the 6, and you get 24. And add the total number of zeros in the problem, 1, 2, 3. Excuse me. And so we can use that when multiplying by a lot of zeros. So zeros are kind of important. So it's good to have ways to process them more efficiently. I want to draw a picture. And it's going to be picture of an office, or basically it's a couple of rectangles, and we want to find the area. So I'm going to start off with just one rectangle and find the area of one rectangle, and then we will make it a little more complicated by adding a second rectangle. All right, so we have this rectangle here. This is an office, a home office. Okay, 9 feet by 14 feet. And we're going to add another piece to this office, right? So, but first, and I'll show you where that other piece is going to be, but we're not going to work with this one right now. This off. So we'll add this piece on later. I'll just have it in green for right now. We're going to keep it in green. But we're going to focus on the black rectangle. Okay, the green rectangle is 5 feet by 8 feet. But if I can ask you to please, let's focus on the black rectangle, which is 9 feet by 14 feet. So I'm going to get the area of the black rectangle, and then later on I'll get the area of the green rectangle, and then the total office, by the way, which is shaped like this, is going to have the sum of the two areas, but for right now, I'm going to focus exclusively here on the black rectangle. So we have area of the black rectangle is equal to 9 times 14. And when I go to write that vertically, I always write the number with more digits up higher. It's easier to keep track of the multiplication this way, okay? 9 times 14 is the same as 14 times 9. It doesn't matter what order you do the multiplication in. So 9 times 4 is 36. And 9 times 1 is 9, plus 3 is 12. So the area of the black rectangle is 126. And now I want to look at the area of the green rectangle. And so I'll write that in green. Area of the green rectangle is going to be equal to 8 times 5, and 8 times 5 is 40. Okay, so let's go ahead and add these, put these on the diagram. So that's 40 and 40 watts, and I should have been jumping in with this, 40 square feet. That's the unit. If you're multiplying, if you're finding area of feet times feet, we call it square feet. So 40 square feet and 126 square feet. So this part here is 126 square feet. And the green part is 40 square feet. So the total area of the office is going to be the black area plus the green area. I'm going to add them up. Let me get a little bit more units here. Okay. So the total area is going to be 126 plus 40. Okay, so that's 126 plus 40, 166 square feet. Okay. All right. And then with one more, we're going to do an estimation problem, an exact problem, and then an estimation problem. And that'll be what we cover today. So I'm going to give the problem to you here, and then you can start to think about it. 412 times 198. So you guys, you can, while I erase and set things up, write that vertically and start to do your multiplication, and then I'm gonna do estimation. Okay. So maybe in the video, I'll just do the estimation. So you can pause it here if you haven't finished and come back and finish it out. So we're gonna multiply 412 times 98, and this is an estimate. So I'm going to estimate 412 to be near 400, and 198 is close to 200. And so I want to multiply these guys, and we had that rule, if there's a lot of zeros, then you just multiply the non-zero part and tack on the same number of zeros that you had in the problem. So in this case, it's 4. Okay, so the estimate of 412 times 199 is 80,000. And the actual value, you can check in with the notes if you're having some trouble finding it. The exact value is 81,000. Okay, so that is one really helpful way to work to use estimation to check your multiplication problems. All right, I'll see you next video.